Yeah. Yes, welcome back to online class. It's today we are going to discussing about crystallography. It's from second semester geology. Today we are going to again discussing about the crystallography forms. Yeah, fundamentals of crystallography, classifications of crystals, then isometric and tetragonal orthorhombic systems, monoclinic, triclinic, and hexagonal systems. Let us see the first the definition of crystallography. Crystallographic concepts of crystallography. Crystallography, it is we know that it is in the sub branch of mineralogy. It deals the study of crystal structure, how it is going from the crystal. Crystal either maybe it is amorphous or a morphous. In ancient days, Greek philosophers observed the solid material in the Alpine mountains of Europe. The substances was bounded by the smooth plane surfaces, and it has a transparent that is that objects on the other side, it could be seen clearly through it. And there may be the luster it was they have found it's vitreous and splendent, and it is looked like a glass and sunlight falling on the surface, whether it's reflect with the brilliancy, giving the clear images. So that those Greek philosophers that thought that is solid was originally it's from water, and it's super cold to like a ice, and naturally and lost the property of melting back to water. What is the first of all crystallography? The crystallography, it is a study of a crystals. It is known as a study of a crystal scientifically. It's known as a crystallography. The scientist they have discussed and studied, investigated about these crystals. The crystallography was developed as a science since 17th century by the efforts of Steno in 1638 of Holland, Delphi, Huguet, Bravias from France. After that, Miller and Barker of England, Pedro and Wolf from Russia, and others from different countries. What it is there and what it is the matter in that one. Yeah, it's occupying that space. It is called a matter. Here the matter, it is called as a substance also. And the matter occurs in a gaseous, maybe it is a liquid or it is in different states. Whatever object if we can take, definitely we can maybe we see and we observe those all are in solid state or different states. We know that the gases actually doesn't have any shape. And the shape of the size and the gas, even we didn't have a chance to measure the weight also. Yeah, if you see into the liquids have a definite size, but do not have any shape. The size of a liquid, or if you take any other constant temperature and the pressure, and its size is not depend upon the container in which we are going to take. Yeah, when you come into this in solids, in your solids, definitely they have a size and a shape. The size of a solid is given, it's a depend on the weight, and it is a constant at a given temperature and the pressure. Its size and the shape are not dependent upon the container in which it's keep rigid, and only some sufficient pressure it is applied on a solid. Then the shape, maybe it is altered, and sometimes it can be broken into pieces also. Here the crystal substances. When crystal we do not show any phases. The crystalline nature, it could be only established by the examining thin sections or a grain mounts of a crystals under a special type of a microscope. It is called as a polarizing microscope. Yeah, such solids said to be microcrystalline. The branch of a science that studies of optical properties of a crystals, it is called as a optical crystallography. Optical studies on certain viscous liquids revealed that they exhibit properties peculiar to crystal in certain directions. Such liquids are called as a liquid crystals. The best example for this is ammonium. The best example for this liquid crystal, it is as a ammonium oleate. We know that some crystals are so small, even when you see into the microscopic methods, sometimes maybe it's a fail, and to establish their crystalline structure, structure. As per that, we see the nature, how it is look like. And we use at the time by the X-ray diffraction methods. Those solids said to be by cryptocrystalline. So such type of science it is called as with using of X-ray diffraction method, so that it is called as X-ray crystallography or X-ray crystallography. Yeah, we know that actually we have the crystal. If you can see the morphological of crystal structures, the crystals are solid state bodies which bounded by the smooth plane surfaces we see. Yeah, those smooth plane surfaces, we know that we can classify into the edges and corners. The external features also we can able to see of these crystals. That maybe we can see that is as a faces, edges, and corners, and it's reflecting into the internal arrangement of atoms. We know that atoms, it's very small particles. Those are all arranged by sequentially, line by line, and systematically, and they have associated very compacting. And those atoms will be making as a crystal structure. The internal structure of these crystals, it's very from one to the another. Suppose if you can see the two crystal systems, and it is a different from one crystal system to the another crystal system because of the internal structure. It is like that, and the internal arrangement of atoms, it is a different from the one crystal system to the another crystal system. Here, wait, sorry. Yeah, coming to the morphology of crystals. As per morphology of crystals, we need to describe their external shape of a form, and crystals have three main external features, such as faces, edges, and corners. These three types are a basic morphological features we have to identify in a crystal. Yeah, what are the faces? We see. Yeah, actually, what it is, the actual definition of a crystal, that is also must we have to know. Is a crystal, is it homogeneous or not? Yes, definitely it is homogeneous. Is it isotropic or anisotropic? Yeah, definitely it is anisotropic. So that we can define a crystal is a homogeneous anisotropic solid, and it is characterized by definite chemical composition and its orderly arrangement of different atoms. Either maybe that's a substance, it should be in a solid, and it has a particular structure. So that finally we can say the crystal definitely it has a definite chemical composition, and its association and arrangement of a different atomic structure. A space list also. Yeah, sorry for your interruption. Yeah, let us come into the phases of a crystal. The important parts of crystals are phases. We know that edges, corners, centers. That means center part of a crystal, axis, zones, planes, and interfacial angles. The first one, it is the most important point. The first one, it is phases. Is any crystal, if you see, that is the crystal, it has a polyhedron and it's extend into the 3 dimensions. The faces are having the plane surfaces, and it is produced by the internal arrangement of atoms. We know that. Yeah, definitely they have a definite shape and size. It is also. And size it is also. And it is produces into the 3-dimensional level. But here it is mentioned 2, but it is a 3 dimension. And it is bounded by different surface, edges, and corners. Yeah, a face, it is plane and extend into 2 dimensions. And it is a polygon bounded by 3 or more sides. A crystal, it is entirely, it's made up of like faces, and then finally it is a result, it is known as a simple formation. It will be visible into the simple form. The best example for this one, cube, octahedron, bipyramids, etc. and etc. And sometimes we can able to see the different faces also. Commonly it is we are calling that is a compound form. And example for this one, octahedron, it is also cube, it will become, and again along with that one, prism and pyramid. Yeah, what about how we can identify the faces? How many faces are there in the one? Yeah, faces numbers is giving the different clue for identification of a crystal formation. For the best example, actually, if you can see the cube, it has how many faces? Cube, it has 6 faces, 6 square faces. And if you can see the same into the octahedron, in the octahedron, it has 8 equilateral triangle faces we can observe. And again, if you go into the tetrahedron, in a tetrahedron, it has 4 equilateral triangle faces, and it has a pinacoids. It has 2 pinacoid faces. And these are all the normal to the one of the crystallographic axis. It will be passes through this is the crystallographic axis, and remaining 2 axes will be also there, and through the center, the remaining 3 axes will be also followed.
Excuse me, sir.
Yes.
The rock ఉన్న క్రిస్టల్ యొక్క స్ట్రక్చర్స్ సార్ ఇవి ఫేసెస్ ఎడ్జెస్ అవన్నవి.
Yes, yes, yes. If you can break this rock formation, we can able to identify different phases in that one. As per that, we see. Again, there are various crystals will be there in a rock. Group of a crystals is aggregating, and finally it is going to be formed as a rock. If you can just example for, if you can see quartz.
సార్ మినరల్.
Quartz, it's a mineral, exactly. Group of minerals, it is making as a rock. If you can break that mineral, we'll get different phases in that. The phases, how it is look like. Suppose if you can see only just a simple quartz, only single amount of a quartz, if you can see one piece of a quartz, it has a phases. The phases, if you can see, it look like a plain surface. It's like a plain
Only,
surface.
sir, only the minerals are only having the crystals, sir, or
Yes.
some other rocks also will be having the crystals.
Yeah. No, it's not like that. Actually, group of a crystals, it is going to form as a mineral. And group of a mineral, different minerals, if you can see into the rock, it is aggregating of different minerals. Just example for, if you can see the granite rock. Granite
Yes,
rock, if you see the granite rock, there are different types of minerals will be there in that one. We know that. Like example of quartz major, after that biotite, muscovite, feldspars. These are all the minerals. And again, if you go into deep study into the minerals, then we will get the crystals. Okay. And again,
okay,
if you go into the deep study of crystals, and then we need to study about arrangement of atoms. And again, we need to study of a atom structure. Okay, this is okay, understand?
Okay, sir.
Yeah. Shall I continue?
Yes, sir.
Yeah, okay. Yes. Yeah, okay. This is about phases. Actually, here I mentioned only just 6. That is the 6 number means it's a cube. Octahedron means it's 8. Tetrahedron means it is 4. It is a 4. And again, if we can divide into that phases, we will get the 2 types of phases. Those we are called pinacoids. Those we are called as pinacoids. So that along with this is the phases. Along this is the phases. We need to study about the edges also. Edges. Where it is the edge will be formed. Where the 2 faces, it is a coincided. Where the 2 edges, it's a coincide. It is the line. The line it is going formed. The line it is called as a edge. The line it is called as edge. Yeah, sometimes maybe the edges are the straight lines which are formed the intersection of 2 faces. It belongs to the same or different formation. Same or different forms. Example for, if you can see in a rock, example for granitic rock, you see granite rock. In that we know that the composition of a granite, it has a quartz, feldspar, biotite, muscovites, etc. and etc. So here, when it is a crystallization, when it's a crystallization of the rock, the first phase it is maybe it is occupied by the feldspar, and along with that one, quartz maybe it will be formed. So that you can observe here, the side edge of, or by the side of this feldspar, maybe the quartz it is going to be added. But if you go into the crystal system, both are different. But when it is in crystallization formation, when it is a forming of a crystallization, so there is a chance those 2 will be formed side by side. So the crystal structure maybe it is different, but the faces, it will be joined at a place. The place it is called here as a edge. So here the edge, it is a look like as a line, and it has a joint of a two faces. It's the joints of a two faces, and the surface maybe it is a different, depend on the mineral structure. Whatever mineral it is going to form, depend on that. That is a different structure it will be looking to. Sometimes maybe it is a formed same. Sometimes maybe it is a formed same, but in sometimes maybe it is not possible. So here, they extend into the one-dimensional or in a different orient, or sometimes maybe it is in a one orient or different dimensions. That's depend on the orientation of three ways with the respect to the crystallographic axis, and the crystal axis maybe it is a horizontal, vertical, or inclined edges. That means just you can imagine. Just close your eyes and you can imagine in your mind. Just you hold in your hand duster or box, square box you can hold. Just you can imagine. What is happening here? In a straight line, that's in a north and south direction, just example for in a straight line you can see that is maybe one axis. It is a horizontal axis, and east and west that is also passing through. This is a square box, and just you can imagine it's a moving horizontal east and west. Then where the some intersect point it will be generated. Through that intersect point diagonally, one more axis will be traveling. So that here, what I'm saying to you, as per a diagonal sequence or as per along the diagonal line, one axis is going on, and horizontally one line is created, and straight north and south one line it is created. So there are three types of axes. Are travel through this is and edges. Okay. Then corner places. That's also must and should we have to see the corner places. A group of edge, it's lie parallel in one direction in a crystal. It is said to be an one set. We are calling that is the one set, and another two sets also will be there. Maybe if it is going to through vertical, or maybe it is going through the horizontally and diagonally. What about the corners? And one more thing here, there is a one principle. There is a one principle or one equation as per our textbook. E is equal to half into F1 S1 plus F2 S2 up to Fn Sn. As per this equation, we have to find out the total number of edges in a crystal. Here, F1 it is indicating the number of faces in a first form. That means when the crystal, if it is in a first phase, the formation, if it is a first, then how many faces are there in that one? how many faces are there? If you can see into the square, if you can see into the square, if you can, in square we have how many faces? In a square, how many faces we have? 6 faces. Top and bottom and sides 4. 6 faces we can able to see. So that we should write that is a 6 faces it has. Or sometimes maybe if it is a metamorphosed, or the formation it is going to be changes. Then the number of faces, the count will be, it is also changed. That is considered as a F2. Based on this principle, we can able to identify the edges, number of edges. Corners. Next one, it is the corners. How we can describe the corner? Where we can able to identify the corner? The corner we can able to identify where these edges joined. Where these edges, the 3 edges, the 3 edges in a 3-dimensional, or 2 edges in a 2-dimensional, there it will be creating an angle, and there it is going to be created one point. The point it is called as a corner. Yeah, we can describe this is as a solid angles, has solid angles, and it is a dimensional, that means a dimensionless feature in a crystal. Dimensionless means as per passing of or transmitting of axis. As per that, we can measure the angle. Yeah, next one, it is classification of crystals. You see here, before going to that, how we can identify the number of corners in a crystal. There is also one equation that was mentioned in our textbook. That is C is equal to E plus 2 minus F. C is equal to E plus 2 minus F. What it is a C? C, it is known as a corner, where here E, it is edges, F, it is indicating the total number of faces. It belongs to the all the forms. As per this, we can calculate. As per this, we can calculate the number of corners in a crystal. The principle, it is equal to C is equal to E plus 2 minus F. C is equal to E plus 2 minus F. And again, we have to know center of a crystal. Center of a crystal. Yes, sorry. What it is the center of a crystal? You see here, these are all the axes, different axes are passing through this crystal. The center, it has all the intersecting points. The center of a crystal, it is located, and it is situated. It is situated in a central point of a crystals. And the point it is going to be coincides with the center of a gravity of a crystal. You see here in a picture, there are three types of axes are passed through this crystal, and somewhere all the intersected at a point, and the point maybe it is a center. Yeah. Axis. What is the axis of a crystal? Axis, it is a straight line. Actually, the axis, it is a straight line. What I told you just now previously. There are three lines it's passed through this crystal. Three lines. You see here, those three lines in a, the first one, it is a C. It is indicating the plus C to minus C. Plus C to minus C. It's a vertical axis. In second one, it is a horizontal axis. That is a plus B to minus B, it is indicating. Final one, it is a diagonal, it is moving. It is a plus A to minus A we are calling. I'll tell you later why it is a, why we are calling plus A and why we are calling this side only plus A and minus A. Here the axis is a straight line and it is passing through the center of a crystal. Yeah, we know that the axis which are cut the surface crystal at the center of the crystal, and it is creating the 2 points. The 2 points are called here the terminals. Actually, these terminals, it is opposite to the each other. The terminals which are passed through the center of a faces, midpoints of edges and corners, and these through these corners, the axes are how they are transporting, and what are the angles it is going to be inclined. Based on these angles, we can say the study of reflections. Yeah. Yes. Yeah, crystals with the three crystallographic axes, those are only the three crystallographic axes are designated here. One, it is A, B, and C. The A and B, you see here, A and B, horizontal axis, and the C, it is a vertical axis. Just you can imagine. A and B, it is a horizontally, it is a C. Horizontally B, we know that actually it is a horizontal, definitely. When you come into A, it's a diagonally, it is a passing. Diagonally, it's a passing. So that's also considered as a horizontal axis. And C, it's in a position of in a north and south direction, and that's a vertical. It's a vertical direction. It is in vertical direction. And each axis Just you can check here. Each axis, it has a plus and minus symbols. Plus and minus symbols. Yeah. Those plus and minus symbols, we are calling that is a positive and negative signs or symbols. The axial angles between the three crystallographic axes designated, we can call that is a AC, CA, and AB. Crystals with the four crystallographic axes. Let's see that. There are four crystallographic axes. Axes are designated. One, it is A, A1, A2, A3, and C. Yeah. The crystal sphere we can see here. Sometimes the crystal sets are having the four crystallographic axes also. You see here, it's coming from the, if it is coming from the top to down, and it is indicating the where the axis it is intersecting, or where two axes are intersecting. Above the point, the intersecting point or the center point of above, it is indicating as a place. It's indicating as a place, and whenever the axis it's transporting or it's moving or it's passing through this center, it is indicating as a negative sign. It is indicating a negative sign. In all the sections, in all the axes, it is applicable. And the angle it is indicating, it's alpha. Or sometimes we can show that is a gamma also. The four crystallographic axes, which are designating as A1, A2, A3, and C. You see here the A1 and A2 and A3 are horizontal axis, and they make horizontal plane. Suppose if the C it is straight, it is called as a vertical axis, and it is a perpendicular to the horizontal plane. It's a perpendicular to the horizontal plane, so that we get the angle at the time 90 degrees. That is maybe a horizontal angle here or a horizontal axis. Maybe sometimes it is a A1 axis or A2 axis. As per that, the end of the axis, it's indicating the plus C, and it is indicating the next, it is as a minus, negative, that is. You can see there are some angles also it is showing. Each axis has its positive and a negative at the extreme ends. Yeah. The symbols of the horizontal axis are placed where it is an alternative position, and the axial planes or axial angle between the two horizontal axes, it is of maybe sometimes it's a 120 degrees, or sometimes maybe it is around 90 degrees. The C always, it is a C axis, it is always, it's a vertical plane, it's always having the vertical plane only. And it's moving from top to nearer to the down. Then it's showing as a 90 degrees angle. It is indicating the plus C. And if it is come down, then definitely it is showing here minus 20 degrees. Sorry. What is the dispersion of axes with the different crystal systems? We know that there are various types of crystal systems are there as per the crystal symmetry and as per the crystal zones of a crystal. Based on that, or based on the angle rotation, the name of axis symmetry, it will be classified. And as per that, we can explain the type of a symmetry plane. Suppose example for if it is a 360 degrees, the rotation of an angle completely, if it has the same 360 degrees, the symmetry symbol we can show that is a 1. The name of axis symmetry, it is called as a monad. Yeah, if you go into the symmetrical plane of the description, it is called as a monogonal. It's called as a monogonal because of only one angle it was there, and only one part it is there, the round part it is there. So there is no dividation in that one. So it is called as a monogonal. Or else, if you go into the 180 degrees, there are two types of dividation parts will be there. In that case, if it is 180 degrees, the 180 degrees means we can expect that's a 2. The symmetrical symbol, it is indicating as a 2. And again, 180 degree, 90 degrees, and 60 degrees. As per this, 180, 120, it is indicating the 3 symmetrical symbols. 90, it is a 4 symmetrical symbols. And 60, it is a 6 symbols of a symmetrical. It is showing. Yeah, if you go into the classification of these crystal systems, there are 6 types of crystal systems are available. One, it is the isometric system or cubic system. Second one is tetragonal system. Third one is orthorhombic system. Fourth one is monoclinic. Fifth one is a triclinic system. Sixth one is a hexagonal system. In an isometric system or cubic system, here the system, it has 3 crystallographic axes. Here, all are the same. All are the equal planes. All are the equal planes, equal length. And it is making to the right angle with each other. And it can be interpreted as A is equal to B is equal to C is equal to 90 degrees. 90 degrees. Because of the crystal system axis, three axes are there. Three axes which are passing through this through the center only. All the crystallographic axes are equal and it has equal length. And the angle it is going to make as a 90 degrees with each axis. So that we can say that is A is equal to B, B is equal to C, alpha is equal to beta, beta is equal to gamma is equal to 90 degrees. Yeah, the three axes, we know that the three axis, it's the front to the back axis. The A2 axis is the side to side. The A2 axis, it is side to side. And the A3 axis, it is vertical. It's a vertical. As the axial ratios, it is unity and axial angles are equal to the 90 degrees. There is no equation to determine the axial planes. Either maybe it belongs to some crystal system. So that here you can see the axes are, you see here, it's below the horizontal line or below the center point. The line, whatever we are showing, that is indicating in different degrees and all are equal. So that what is happening? A is equal, B is equal, C is equal to 90 degrees. And second one, it is Tetragonal System. Tetragonal, yeah. Tetragonal System. The two out of three crystallographic lengths in a height, or maybe it is equal in length. While the third axis just wait, I will. Yeah. Here, it is indicating the A is equal, B is equal to C in the first cubic system. If you go into the tetragonal system, here also it's the same. A is equal, B is equal to C, and it is equal to 90 degrees. But here the two crystallographic axes are equal in a length when we are compared with another one. And it's making the angle of 90 degrees in all. That's maybe sometimes it is indicating A is equal to B, not equal to C. At the same time, alpha is equal to B, alpha is equal to beta, beta is equal to gamma, gamma is equal to 90 degrees. So here, A is equal to B. The A is equal to B, it is indicating these two are equal axis. The length, it is equal. Or sometimes if you go into, see, in a angle level, that is alpha is equal, beta is equal to gamma is equal to 90 degrees. But there is no change here. There is no change here. But whenever the angles, it's passing through this one, the angles are equal, but in axis lengths are different. That is, we have to identify. And coming to the third one, orthorhombic system. In an orthorhombic system, here the three axes are not equal. You see the differentiation from first to second, second to third. In a first one, in your isometric or a cubic, iso means equal, equal. Iso means equal. All the axes or lengths are equal. But in a tetragonal, only any two angles, only any two axes are length, it is equal, except one. Coming to the third one, if you can see into the third one is a completely it's unequal length, and it's making the angle, and it should be again it's 90 degrees, so that we can say here as per angle it is equal. A is equal, B is equal to 90 degrees, but when you go into this axis level, the axis angle, that's also may be equal, but the length is different. So it is indicating as a alpha naught is equal to beta naught is equal to gamma. Gamma. Yeah. Next one, it is monoclinic system. And here also say the three crystallographic axes are in a different length. The V axis is aligned normally. Yeah, the B axis is aligned normally. A and C axis, it's a B axis lies normal to the two axes. What are those two axes? That's A and C axis. That is A naught is equal to B naught is equal to C. And A alpha is equal to gamma is equal to alpha is equal to gamma is equal to 90 degrees. Whereas 90 degrees, it's not equal to the beta. Because of the position of B axis is fixed, and it is coincides with the singular axis, and that lies normal to the AC axial plane, and it's containing the innumerable singular axis. So if you wanted to know about the elements, must also we have to know about A by B and C by B ratios. Next one is Triclinic system. In a triclinic system, all the three crystallographic axes So here we can say that is A naught is equal to B naught is equal to C. And if you go into the angle, that's also alpha naught is equal to beta naught is equal to gamma. And finally, it's not equal to 90. In different angles, they may angled in a different value. That's maybe sometimes it's a 60 degrees or a 40 degrees, and 60 degrees and 40 degrees. And one more value, it is 80 degrees. That's one thing. And hexagonal, when you come into this hexagonal, in a hexagonal system, it has a 4 crystallographic axes. And there are horizontal axes, and they lie in horizontal plane. These 3 axes, it's sometimes it's equal. It's equal length, and it's going to make the angle, it is 120 degrees. It's going to be make as a 120 degrees. So here, all the axis lines are equal. The equal length it has. In a hexagonal system, it has the equal length, and the angle, definitely it is 120 degrees, or sometimes it has 60 degrees. Okay. These are all the basic crystallographic types. And we see it in tomorrow class, the symmetry of crystals. And in that, we see the plane of symmetry and systems, and how we consider the Miller index. That is we see in that in that unit. That's we'll start tomorrow. Thank you.
Sir, is there any written material with you, sir, regarding these units?
Material, okay. Send just your WhatsApp number. I'll send you.
అది సార్ అంటే ఇప్పుడు మనకి నార్మల్ ఫిజికల్ జియాలజీకి కేఎం బంగారు ఉంది కదా సార్ టెక్స్ట్ బుక్.
అవునవును.
అలాగే దీనికి ఏమైనా ఉందా సార్? అంటే టెర్మినాలజీ కూడా కొంచెం టెర్మినాలజీ ఉంది.
మీకు యూనివర్సిటీ బుక్స్ అందలేదా మెటీరియల్?
అందింది సార్. దాంట్లో కొంచెం టెర్మినాలజీ కొన్ని గట్టిగా ఉంది సార్, అని చేత ఇంకోటి అయినా బుక్ అయినా ప్రిఫర్ చేస్తారా అని చెప్పి.
ఓకే ఓకే. మీరు అన్నట్టు ఇప్పుడు కేఎం బంగారు బుక్ ఇట్స్ సఫిషియంట్ టు యూ. ఇట్స్ ఎనఫ్.
ఇది ఏంటి మినరాలజీ, దీనికి కూడా సరిపోతుందా సార్ కేఎం బంగారు?
దానికి సరిపోతుంది అది, ఎందుకంటే ఇప్పుడు మీ డిగ్రీ బేస్డే కదా ఇది. సరిపోతుంది, ఏం ప్రాబ్లం కాదు.
మీ దగ్గర రిటర్న్ మెటీరియల్ ఉంటే కాస్త పంపండి సార్.
అర్థం కాలే.
మెటీరియల్ అని ఉంటే పంపండి సార్ మీ దగ్గర.
ఓకే ఓకే ఓకే. వాట్సాప్ నెంబర్ నేను చాట్ బాక్స్ లో పెడతాను, తీసుకోండి. మీరు మీ నేమ్, అది మీ ఇయర్ రాయండి, నేను మెటీరియల్ పంపిస్తాను. ఏమైనా పీపీటీస్ కానీ ఇంకా ఉంటే మీ వాట్సాప్ పెట్టేస్తాను. ఓకేనా?
ఓకే సార్.
ఓకే. నెక్స్ట్ క్లాస్ రేపు ఉంటుంది. రేపటి క్లాస్
మినరాలజీకిను క్రిస్టలోగ్రఫీకిను తేడా ఏంటి సార్?
ఏంటిది అర్థం కాలే.
మినరాలజీకిను క్రిస్టలోగ్రఫీకి.
యా, క్రిస్టలోగ్రఫీ అంటేనేమో ఓన్లీ మనం క్రిస్టల్స్ గురించే మనం డిస్కస్ చేస్తాం. క్రిస్టల్సే. మినరాలజీ అంటే మినరల్స్, డిఫరెంట్ మినరల్స్, డిఫరెంట్ మినరల్స్ గురించి దాంట్లో డిస్కస్ చేస్తాం. రేపు డిస్కస్ చేద్దాం దాని గురించి. మినరల్స్ కూడా మనకు రేపు ఉన్నాయి. వాట్ ఈస్ ద డిఫరెన్షియేషన్, మెయిన్ డిఫరెన్షియేషన్ బిట్వీన్ ది క్రిస్టల్స్ అండ్ మినరల్స్. ఓకే
ఓకే సార్.
నేను ఇక్కడ వాట్సాప్ నెంబర్ ఇది పంపిస్తున్నాను, ఇప్పుడే చూసుకోండి సార్.
ఓకే సార్. మీ పేరు సార్?
నా పేరు డాక్టర్ విష్ణు.
ఓకే సార్.
ఓకే, డాక్టర్ విష్ణు భూపతి. జస్ట్ యూ కెన్ save this number and send your name and batch subject, because of I have so many students.
Yes sir, yes.
Okay, right. ఎవరు ఆల్రెడీ మనం గ్రూప్ లో ఉన్నామని పెట్టినారు కదా, వీ హ్యావ్ గ్రూప్ ఆల్రెడీ సార్. అంటే ఇక్కడ ఉన్న స్టూడెంట్స్
అంటే ఇక్కడ మాకేం గ్రూప్ లేదు సార్. అంటే మేము రాజమండ్రి బ్రాంచ్ మాది.
ఓకే ఓకే,
మాకేమీ గ్రూప్ లేదు.
సరేలేండి. ఓకే, మీరైతే పంపిస్తాను.
ఓకే సార్.
ఓకే, రైట్.
థ్యాంక్ యూ సార్.
యా, వెల్కమ్.